Hey, welcome to another junior probability video. In this video, we're going to talk about experimental probability. And when we conduct a mathematics experiment, we can use the results of the experiment to estimate the probability of an event occurring. In a couple of videos ago, we chatted about the theoretical probability. And this is the probability calculated based on the theory of what should happen if an experiment was to be conducted. Well, now we're going to chat about experimental probability. And this is the probability calculated based on what actually happens in an experiment. So you can see theoretical is what should happen, experimental is what actually happens. And quite often these two are not the same. Experimental probability is often called relative frequency. All right, here's example one. A die is rolled 6 times. The theoretical probability says that each number is equally likely and has the same chance of coming up, so we should get one of each number. We should get 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. That's the theoretical probability. But the experimental probability from one experiment conducted showed the following results. And let's look at that in a little bit more detail. You can see the probability of getting 1 was 0 because we didn't get any ones. Probability of getting the number 2, we got 1 of them out of 6 rolls. Probability of getting 3, we got 1 out of 6. Probability of getting a 4 was 1 chance in 6. Probability of getting the number 5, we had 2 of them come up in the 6 rolls, and the probability of getting a 6 was 1 chance in 6. Now, the theoretical probability says we should have got one of each, but the experimental probability shows some different results. All right, example 2, die is rolled 600 times. So the theoretical probability says, once again, each number is equally likely, and so we should have the same chance of getting each number, so we should get 100 of each, 100 ones, 100 twos, 100 threes, 4s, 5s, and 100 6s. The experimental probability from one experiment conducted showed the following results. So let's look at this diagram in more detail. The probability of getting 1 was 110. We didn't get 100 of them, we got 110 out of 600. Probability of getting number 2, that was the greatest, 115 out of 600. Probability of getting a 3, well, we only got 98. Actually, that's pretty close to 100. Probability of 4, look at that, we only got 88 4s out of the 600. Probability of 5, we got 93 out of 600. And probability of 6, we got 96 out of 600. So you can see the numbers 3, 4, 5, and 6 were below what we expected in the theory, and the numbers 1 and 2 were above. But that's only one experiment that we've conducted. Right, example 3, a coin is flipped 20 times. The theoretical probability says we should get 10 of each, 10 heads and 10 tails. But from one experiment conducted, this is the experimental probability, and this is the results. Let's look at this in more detail. We got 6 heads and 14 tails. So the probability of getting a head was 6 out of 20. The probability of getting a tail was 14 out of 20. Right, our final example is this here. Tina is a striker in a football team. So far, she's played 12 games in a season, and a summary of the goals she scored is shown here. So we've drawn a bar graph that represents her getting 6 times where no goals were scored, 3 times where she scored 1 goal, 2 times where she scored 2 goals, and there was 1 time she scored 4 goals. So we can work out the experimental probabilities. The probability she got no goals was 6 chances out of the 12 games, which is 50%. The probability of getting 1 goal was 3 chances out of the 12, which is equivalent to 25%. Probability she got 2 goals, 2 out of 12, 16.7%. The probability she gets 3 goals is 0% because she never scored 3 goals. And the probability of getting 4 goals was 1 out of 12, which is about 8.3%. All right, well, that's experimental probability. So thanks very much for watching.